Trying to understand AI agents, LLMs, and workflows? Yeah, the search results are a mess. It's all jargon and complicated charts that just make it more confusing. It doesn't have to be. Let's clear it up for good. We'll use one simple diagram to see how they all fit together and what actually makes an AI agent so powerful. If you enjoy our content and want to see more, don't forget to hit subscribe. AI agents are discussed everywhere right now, but not everyone understands what it is. In this video, I will explain about AI agent and related keywords like LLM, AI workflow, etc. Let's start with large language models, often called LLMs. Popular AI chatbots like ChatGPT, Google Gemini, and Claude are applications built on top of large language models, LLMs, and they're fantastic at generating and editing text. For example, if I ask ChatGPT to write a short text asking a friend to meet for dinner, and the model will quickly draft a friendly message based on the prompt given. But when I ask, now tell me what time my dinner with Sam is, and the model won't know because it can't see a calendar or any private info by itself. This shows two things. They don't know private or live data like a personal calendar unless connected to a tool, and they wait for a prompt before replying. Keep these points in mind. Now consider I provided my LLM access to my calendar through API. Now it can access my schedule and provide correct response based on my query. This network is called AI Workflow. You can increase the AI workflow by adding more other APIs like weather, text-to-voice. Now it can answer my query like, check my schedule with Sam, and provide me the weather of that day in generated voice format, and I will get a result voice. This chain of apps and steps linked together is what is meant by an AI workflow. But if a request falls outside those steps, the workflow will not adjust on its own until the steps or the prompt are updated. Here is where AI agents come in, and why they feel different from regular workflows. In AI agent, user does not provide a prompt but a goal to the workflow. Instead of only running a fixed set of steps, the agent in the center takes a goal, figures out the steps, picks the right tools, acts, checks the result, and loops until the job is done well. For example, here AI agent checks the calendar to find the next free slot with Sam. If that time conflicts, it tries another slot instead of stopping at an error. Then it pulls the weather for that day. If the forecast looks bad, it can go back, pick a different time, and check again before moving forward. Next, it drafts a short confirmation note and sends it to text-to-voice. If the wording isn't clear, it revises the message and regenerates the audio before producing the final output on the right. The key idea is that the agent chooses and reorders these tool calls on its own to reach the goal, instead of following a single fixed path with green checks from left to right. If something changes, like a new conflict on the calendar, the loop simply runs again, trying a different time and updating the message and audio until the result fits the goal. Now I'll show you a live coding demo that compares how an LLM and an AI agent answer the same question, so we can see the difference in their approaches. Here you can see I have created a notebook for comparison. You can download this notebook as link is in the description. Now, let's see this in action. In this notebook, I've set up two scenarios to compare how a pure LLM and an AI agent respond to the same question. What are the main differences between a pure LLM and an AI agent? First, the LLM. As you can see in the code here, we're making a direct API call to a locally running LLM, in this case, Qwen257b. We send the prompt directly to the model. The response is exactly what you might expect. It's a well-written textbook definition based on its training data. It tells us that an LLM is a computer program that can understand and generate text, while an AI agent can make decisions and take actions. It's correct, but it's based purely on the information it already knows. Now, let's try this with an AI agent. Using the Small Agents framework, I've created a simple agent. The key difference is that I've given it a tool, in this case, DuckDuckGo search tool. Now, the agent can search the web to find the most current and relevant information. The question is the same. What are the main differences between a pure LLM and an AI agent? Let's run this and see how its approach differs. The question is the same. What are the main differences between a pure LLM and an AI agent? Let's run this and see how its approach differs. Look at that. The agent's process is completely different. Step 1. It immediately recognizes that it needs more information, so it decides to use its tool. You can see it executing a web search for our exact query. Step 2. It then parses the search results, analyzing the information it found from various online sources. And here is its final answer. This answer isn't just pulled from a database, it's synthesized from the live information it gathered from the web. It took a goal, broke it down into steps, used a tool, and constructed a new, informed answer. If you'd like to explore practical resources and hands-on examples, we've created a dedicated GitHub repository. It's filled with cookbooks covering computer vision, AI agents, and more. Link is in description.